How's everyone going? Does anyone need some help? Anyone stuck? Okay. I could probably even get to you, actually. Okay.
Before we're done, would you be willing to a quick conceptual difference between the other higher level types, like the prisms?
Yep, absolutely, I can do that. Yeah, I installed the package over lunch, so I'll be able to show you the real deal. Yeah.
Cool.
Yeah, we'll do that.
For,
I'll do that in a minute.
So I know when to go look up how to use them.
Yeah, so I'll give you the conceptual idea, right, and then I'll come up with some. I'll find some examples that I've used them before. But yeah, I'll try and give you the model in your head to hold to start using them. Yeah, I'll show you that in a minute, actually. Yeah. Haskell problem?
Yeah.
Yep.
How can I define an anonymous function where I can do some pattern matching parameters?
Okay, so lens. I think you need to indent undefined as well. Is that right? Or does it compile with undefined?
It compiles.
Oh, right. Okay, sorry. So I'm not sure what you're asking then.
Here I have something.
So that's the getter, right?
Yes.
Very, very similar to...
Basically, it will be a header.
No. So just put undefined there for me, and then put underscore undefined, and then let's go and ask the type checker. All right. So it will be either A, B to X. All right. So
I'd like to, pattern match.
Yeah. So you want to do an inline pattern match, right? Yeah. So I'll show you how to do that.
Okay.
So yeah, you need parentheses like you were doing. Okay, and then you say so lambda the e, like lambda the either, whatever it's going to be, arrow, right? And then you want to say case e of, so case space e of, and then you want to say left.
Okay.
And then the value with the left, so there'll be, and then arrow again, right arrow, and then what to return for left. Okay. So just put undefined there, yep. And then I usually come down on the next line under the L on left.
Okay.
And then I say right.
Okay.
Yeah. And then another value, because right carries a value, and then arrow, and then,
okay.
Yeah. Does that make sense?
Yeah.
Yeah, cool.
Thanks.
No worries. Yep, no problem. How you going?
This choice.
Yep.
What's the general idea behind it? Is it...
It's so basically you want to say given two lenses, right? You want to combine them together so that they split on like A or B sort of thing. So you're turning. Yeah, I mean it's really hard to explain other than what the type says.
That's what I'm trying to.
So things like let me just have a look at this, right? So yeah, that composes those. Oh yeah, sorry. Yeah. So first, second. Yeah. So if you want to say choose between the first and second side of a tuple,
right?
And then you do.
Right. Okay. I got it. Yeah. Okay. I think because so then when you're operating on the other type, they're both fixed in what's on the tuple of
I'm trying to actually remember. This goes back to a structuring category theory that I've forgotten. It's the dual of a tensor. That's all I can remember.
Okay.
But yeah, I don't know what to say other than what that type says. Okay. Yeah, it's like you're given two lenses and they split into A or B, where A and B are the target types on the original lenses.
Okay, and it's really just in order to get the answer correctly. It's just a question of following types, really.
Yeah, if you follow those types, let me just think now. Can you get it wrong? You can get it wrong. You are unlikely to get it wrong.
Okay.
Yeah, I mean, you have to do a significant cheat to
Okay.
get it wrong.
Okay.
I think that's right. Yeah.
And I have one other question for you. Is this in any way, shape, or form related to? I think there's a choice. I don't know
Oh,
if it's-
in the pro functors package.
Yeah.
It is very loosely related.
Okay.
Like very very loosely. Yeah. Yeah.
Okay. Thank you.
Yeah. No problem.
I probably couldn't have got there without seeing your F-modify first. Yes.
So yeah, to answer the question about developing intuitions for these things, so let's first look at the definitions a little bit. So going back to this table here, this diagram. So I'll show you, I guess, ISOs, prisms, and lenses, and traversals. Let's just pick a few. All right. So if we have a look at I guess like a base type, I guess, or something to think about is everything we're about to look at will have this structure, and we'll specialize on this structure. All right, so this general idea has often been named an optic, like optic, optic P STAB or something like that. And F, yeah. So actually, I think I can just go info optic. Yes, there it is. PF Right, so everything will have this structure. So at the very top of that diagram is ISO. Well, we'll ignore that. That's ISO. There's actually not a structure for equality anyway. Actually, that is the structure. Optic is the structure. But if we have a look at an ISO, we'll see that I don't need the definition of P. We see that it is of this structure. However, these variables are constrained somewhat, and that is to say that P has a pro-functor instance and F has a functor instance. And what's most familiar probably is like the functor applicative monad hierarchy. So like functor sits at the base of that hierarchy, and there's an equivalent hierarchy in the idea of pro-functors, and profunctor sits at the base of that hierarchy as well. So these are like two very weak constraints placed on P and F, and that gives us an ISO and isomorphism. So the idea of an ISO, or I think it's pretty easy to develop an intuition for an isomorphism. That is like there's a bijective function between the two sets. So does everyone know what does anyone not know what an isomorphism is? Right? Yeah. So basically, you might have a data type with two constructors, Boolean, and then you have another data structure that swaps them around, the negation function, to another data structure. And the thing is there's a mapping from one set to the other one, and they do not hit each other at the same element, going in both directions. And that makes it a bijective function, and therefore you can, in order to construct that ISO, basically you pass in the function to go one way and the function to go back the other way, and then you get back an isomorphism. Right, so I could do something like the type of ISO ID, that is, given a Boolean, just return it, or not. There is no not in scope because I don't have data.bool. What? Oh, ID as well, sorry. Yeah, Prelude's not here at the moment. There we go. Right, so that gave me back an isomorphism. So that's the idea of an isomorphism, is it's not viewing a field inside a structure. It's exactly from one thing to another thing and back again in a bijective fashion. And then moving down in that diagram, if let's just take a look at lens, which we are looking at, but we'll have another look at it. We see that this is similar to what's in that optic source file. We see that it's an optic. However, P has turned into an arrow, so it's been specialized down to be an arrow. It's like a specific value for P, and the constraint is a functor. Right. So this is a strictly stronger constraint that was on ISO. Right. So ISO just said this only has to be a profunctor, but now it says it has to be this specific profunctor, and this constraint remains equal to the one from ISO. So this is now the same type but with stronger constraints on it. And then if you look at the table, the diagram, it branches off in the other direction into prism. So when we have a look at a prism, we see that P did change. It became slightly stronger, but not quite as strong as being so specific to be the arrow. Right, so choice in the profunctor hierarchy, choice sits under profunctor. So all things that have a choice have a profunctor. So P has been constrained slightly more, but not so much as it was for lens. And the functor constraint has also strengthened. Okay, so compared to lens went really strong in one direction by making P the arrow, but did not go any stronger in the other direction, which was functor for F. Whereas prism is the other way around. It went slightly stronger for the P, but not as strong as lens, but definitely stronger on the F. And continuing that, traversal, you'll see, takes prism one step further and says not only is P choice, it is a specific P, and that is the arrow. Right, so it's all about these tightening of constraints in terms of their definition. Now, what does that? That's sort of the definition of it, but that doesn't give you the intuition for how to apply them. Now, for lens, for isomorphism, it's simply a bijective function. You're going from one set to another one, and you can get from there and back again without losing any information. I think that one's pretty straightforward. For lens, you are viewing a product type. Right, so that is, you have A and B and C, and you want to view the B inside that product of A, B, and C. So the key word there to look for is and. Like you've got A and B and C, and that's why the example I showed you earlier, when I can get it, it's actually here, which was in not that one, that one. the example I showed you earlier was a product type, and that is to say, this data type is made up of this thing and that thing, and so on. It's made up of the product of things. And the intuition there is, this tells me lens, or at least lens, I should say. All right, so there could be something more to observe that where I'll tighten that observation, but for now it's just lens. It's this and that and so on. So like I view the latitude value through this record type or product type. Now, having said that, I guess the jewel of that is the prism, where it's this or that. All right. So, who's not familiar with the either data type? It's in the source file. So, does everyone know that data type? So we all know that either is left or right. Either is either left or right, and the thing is that we view an A. So given an A, either A or B, we cannot say that we can view an A as we would a lens, right? Like either does not contain an A, it might contain an A, or it might contain a B. So the intuition there is prism. And in fact, if in the real package, in the real code, there is a lens, a prism called left, _ left, right? And you see here that these constraints are the ones that are equivalent to make it a prism. So P is choice, F is applicative, and therefore it gives us a prism from either AC to either, it's doing polymorphic update as well, right? So if you think of this, if you think of A's and B's as the same thing just for a moment, it's saying look at the left side of either through A as if it were A. All right, does that make sense? So prism is we might have a thing in a sum type. That's the intuition to there for that one there. So lens is looking at one thing inside a product type. Prism is looking at 0 or 1 things in the sum type, because an either may have 0 A's or 1 A. Yeah.
One of the exercises has a lens from a map of PK value to
Yeah.
PK value.
Yeah, it does.
How is that different from prism?
So let me just remember this exercise actually. So,
Yeah, the map L.
oops, it's in this one.
It's in both that and yeah. It's like
Okay. Math L is it called?
Yes. So how is a lens like that different from prism?
The reason, so the reason is, just to kind of read this out, right? Given the key that's in the map, return the maybe V, and it is definitely the case that there is exactly one maybe V inside the map for a given K, right? So to phrase your question and tell me if I get it wrong, which is, what about a prism directly to a V for a given K? Because there are 0 or 1 V's, right? And the problem with this is that it's not a lawful prism, if I remember rightly. That's from the top of my head. I'd have to check. And the reason, so like for example, it's hard to give you an intuition for why that's not lawful, but I'll try, because when we talk about this particular lens, when we say, when we set the value to nothing, so like the maybe constructed nothing, we eliminate that value out of the map. And so you can see there's like the get set is consistent with what a lens does, right? And so the intuition for a prism does not satisfy, like I'm telling you the laws intuitively. So if you apply that same reasoning to this prism that could possibly exist, we see that this doesn't hold.
So with the prism, it would be like a set that exists.
Sorry? So let me just...
I'll probably ask you after this. I don't want to...
No, that's fine. It's okay. So, okay, here's another thing to think about, right? So there does exist a prism in, there exists this prism, the just prism, right? and it views an A through a maybe A. So we all know that there are 0 or 1 A's inside a maybe A, and so of course it is a prism. That's correct. However, in order to get to this V, I would need to compose, like I could just call compose with this lens and that prism, right? And the problem is this is not going to give me a prism because of the way those constraints unify. They do not unify at prism, they unify at traversal. So the thing you would get is a traversal, right? So as long as you're cool with that being a traversal, not a prism, then yeah, that's perfectly fine. But I think you'll find if you write that prism that you think might exist, you'll find that it won't satisfy the laws. Yeah. And this is an example, by the way. It's a good example of, you know, while we think of lenses often as fields of records, this is not a field of a record, right? Like a map does not have a field of maybe V's, like a set of fields of maybe V's. But it's still a valid lens, right? So all it needs to do is satisfy those laws. Yes. So continuing that. So lenses are viewing one thing inside a structure. Prisms are viewing 0 or 1 things in a structure. And traversals are viewing 0 or many things in the structure. So there used to be this problem, it was called, what was it called? The multi-view update problem, I think it was called. Basically imagine you had a recursive data type, and through that recursive data type you had, like, I don't know, a set of strings, right? So you have a string and then the constructor has yet another string, and it became this tree of strings, and you wanted to view all of them and perform a lens operation. Like, let's say you wanted to reverse all the strings or something. And instead of sort of the intuition for lens being view one string inside this structure, we wanted to look at all of the strings inside this structure and update them all, let's say. And in the older representation, we didn't quite know how to solve that problem, and so we wrote really terrible code to get around it. But the more modern intuition for that is a traversal. So that's basically like view many things through this structure, right? So consider this data type, right? Now it is true that I could write a lens for that field and a lens for that field, right? Because I'm viewing one string inside the structure, but it is also true that I can write a traversal to string that'll update both of them, however many there might be. So that's the intuition for those. Does that help? Yeah. So, and I just thought I'll show you. Again, this is the real code that I use. So in that ADSB transmission data structure that I showed you, there's a field called the emitter category, and all that does is identify the weight of the aircraft, what kind of aircraft it is, and that's here it is here. So an aircraft may not emit in a category at all, and basically it's transmitting its weight category, and these are all the weight categories that are in the ADSB protocol. But you can see that this is not a record, this is a sum type. And so the intuition here is to make prisms, and in fact you can see that line of code there. That makes all those prisms for me. So because all of these constructors take no arguments, so they take in effect a unit argument. Does that make sense? Like if I change this constructor here to do this, that's the same constructor in effect. So all of the prisms are viewing unit through an emitter category data structure. So if I drop back down into GHC and I ask, for example, the heavy, is it? Oh, that's the constructor. That's the prism there. Yeah. So we see here that and it's on a type class. So this R0 here is emitter category for the instance. So it's basically view this constructor through an emitter category to the value unit. So we use a prism there because it's viewing 0 or 1 unit values through that constructor. Does that make sense? Yeah.
What's the value of the
imagine I had, and I don't, but imagine I had yet another sum type that had a constructor that had an argument emitter category. Right? So I'll write it just to, rather than writing code in the air. So there I have some other data structure, and it has constructor 1 with, say, an int, but it also has constructor 2 with emitter category. All right. My argument here is I can also view, in this case it was called heavy, the heavy constructor. I can view the heavy constructor through this data type. All right, and that is to say it goes first through this prism, and then the heavy prism, and by that I get to the unit. And what it allows me to do is overload that name heavy. I can go ahead and instance the type class here, and the heavy prism becomes polymorphic in the data type through which we view the unit. So I'm essentially overloading the name heavy in this case for that constructor.
Are you saying you could use this prism directly with the other constructor? You wouldn't have to compose the C2 prism and the heavy prism?
I would have to manually write the instance, right? So that there's no in the case of I'll write the code, right? So so the code currently looks like this, right? So emitter category, category. So there's a heavy constructor, and then there's the others, right? And when I say make classy prism, it does this, right? It says, first of all, as emitter category, x, where, and let me just check that actually. Right. And then it creates a prism called heavy. It creates many things, but this is the one we're interested in, where it's a prism of x to unit. All right. And what it does is it also generates the instance of as emitter category for emitter category, where heavy equals, and then it writes the prism here. All right. Does that make sense so far? And so all of this code is generated by that make classy prisms. But the thing I might handwrite later is I do the following. So actually, imagine also that there's another prism for that constructor. I just make classy prisms for that as well. But on top of that, I manually write this instance, which goes like this: as emitter category, something else, where, and heavy is going to be, it's going to basically go down through this prism and then through this instance here. So basically the instance is just composition of the two prisms, right? So I can look at 0 or 1 things through which I can then look at 0, 1 things by composition of the two prisms. And like the actual code would be like this, right? These two prisms that would get, there's underscores there, but
Would it go that way or the other way around?
I think it's that way around. I don't have a type checker at the moment to check, but I'm pretty sure that's right. So the point is I have now overloaded the name heavy to not be specific to emitter category. It's to anything through which I can view that unit value, for which emitter category is 1 instance, but I can build things on top of that through which I can also see it.
I have one more question.
Okay.
Something else at C-Tort 3 is also emitter category?
Yeah.
How is that?
Yeah. There's no resolution to that. Yeah.
Okay, so if we have an emitter category of something else,
Yeah.
we're also implicitly asserting that an emitter category.
That's right.
That it's something
Yeah, I have to call it. I have to call the shot at some point. Yeah. If that were the case, I'd probably not to write any instance at all.
Could you theoretically have an instance that would point out close to the category field?
Yeah. So what would I really do, right? I could write a traversal for both of these, and then write that on a type class, and then instance that at something else, and then compose it on top still as a traversal. Like a traversal and a prism makes a traversal. Just you can tell that by looking here. Yeah, where's prism there? So you know where prism and traversal hit is at traversal. Or as is the real case, I actually have a lens and a prism, right? So because it's that traffic data type. Yeah, there's traffic there. So there's the emitter category. So a traffic has a lens to an emitter category, and then an emitter category has a prism to heavy. And if I compose those, I'd get a traversal. So that you can actually get really fancy and make those type classes really general, so they don't even say lens or prism. Yeah.
Have you had a few fields? What would the type of prism look like?
It would be whatever the fields are. So a prism from emitter category to whatever those fields are. So let's write one. I can just do it here, I guess. Have I got lens? Make classy and lens. So if I create a data type, and so what did we say? If hang on, if heavy had yeah. So let's just say int or string, right? And we go is int or is string. And I said make classy prisms int or string. What's going to happen there, I'll write the code, is it's going to go class as int or string x where, and it's going to go is int of type prism. Now there's a prism type alias for when it doesn't do polymorphic update. So you know how prism has 4 type variables. If I do that, it now only has 2, and it just makes them all the same. Oh, sorry, it makes the first 2 the same, and the first and second the same, the third and fourth the same. And the reason is we don't want polymorphic update here. There is no, we're using concrete types here. And the thing that goes here is the list of constructors, the list of constructor arguments for that constructor, and in this case it's just int. And then, it's x to int. And then it'll generate an instance, and that instance will be there for that. And it will also generate, similarly, is string for that. And then it'll go is int, and it'll write this prism, right? And I'm trying to remember how to do it off the top of my head. It'll be something like, so. I can't use GHCI now. If I do that, what was I going to do? Look at the type of prism. So constructing a prism using the real library, right? So the type of prism, there's a couple of ways, but the one I'm going to use here is this one. Right, and basically it says, given a function from a construction function, so a prism can always, the constructor can always construct, but given the value, it's not always that constructor, which is why this maybe appears here. All right, so the instance will look like this. The construction is quite simple, where the constructor goes here, and in here it goes, well, given an int or string, if it is that constructor, then return that in just, otherwise put it in nothing. All right, so it'll generate that instance. And it'll do the same thing for isString. Okay, does that make sense? So it's just the list of it's a prism from the target type to the list of arguments in that constructor. And if there are no arguments, that's the same thing as unit.
And it would be a tuple if there were more than one.
It'd be yes, it has to be actually, yeah. Otherwise, it won't be lawful. Yeah, that's right. Yeah, so I guess to kind of motivate this kind of writing of code, there's a few arguments to be made. The first one is, how often do you write record types and sum types? Well, the answer is all the time. That's what writing Haskell is pretty much all about. Then the second question is, well, within the Lens library itself, how many of those functions would I really need to interact with the API? Right. So take, for example, this is reading aircraft ADS-B signals. How often do I want to dig down inside data structures and do things? And I would argue that the answer is quite often. Like, for example, I want to get the latitude and longitude out and check if the aircraft is on a collision course with my aircraft, for example. You know, like, we can come up with all sorts of things. But the point is, the motivating factor is the code. A lot of the code that you would otherwise write is already in the Lens package, which is why I tend to argue you're going to use Lens or you're going to rewrite it. Just pick one. And yeah, I mean, I tend to just write lenses and prisms for every single one of my data types because I know I'm going to use it. Yeah.
Do you ever sell like this to platform? Do you ever write lenses to couple platform?
Yeah, so that's what the product Lens does, I think. Yeah. So basically, if I take this lens, and you've seen the product function in the exercises? Oh, okay. I'll show it to you. Well, let's just pick this one here. I think I've called it product. Yeah. So given a product, you know, from one target to a field, return a lens that takes the pair. There is a tendency actually to, what's going to happen here is that both of these are going to be the target type. It's going to be the pair of the target type. And there is a tendency to want to unify these two types into just one. So look at both things through the one target type. And it turns out that's not a lawful lens. The analog of that is, is that going to work? Yeah. So have you ever messed with this package? I last did many years ago. This is the equivalent of gluing two things together into a tuple, but you're viewing the pair of things to a pair of other things. But there's sort of an analog equivalent to that, which is this function here, which unifies these two target types. This is a completely different package, but the same sort of theory. Unifies these two target types into this one type. But if you take the analog of that into lenses, you'll find that the thing you write here will not be a lawful lens. So I'm not sure how much sense that makes. But yeah, this is how you do that. Use product. But there is a limitation, and that limitation is the thing that you really want is not a real lens. Yeah. But this will work anyway. Yeah.
Can you explain setting your product? I don't understand the
Sorry, setting is in this
The dot has set 5, 2, 3 there. What's that doing?
Give me one sec. So what is it doing? Okay. In this test here, so that is a pair of pairs, and it composes the first and second. Takes the product of the first and second lens, and it's saying, so within the Yeah, I guess that's confusing because the lenses that I'm passing in this position use pairs as well, right? So basically we end up with pairs of pairs down in this part. So yeah, I mean, I don't know how to answer it other than just say, you know, it's setting the first side here and it's setting the second side here because of the nature of the product. So you can see here that this value went into that position, and this value here went into this position here. Yeah, but it is confusing because this type mentions pairs, but this particular use case also mentions pairs, which makes this become pairs of pairs. All right, hope that helps. Cool. Hey mate. Yep.
I'm working on GetSetLens here.
Uh huh.
I'm working on map.
Yep. Yep.
And
In the get set right, eh? Yeah.
and I'm getting an error message I don't quite understand.
Oh, okay.
It's just for this part right here, the
Mhm.
getter, right?
Mm-hmm.
It should be returning a maybe, right? A maybe,
Yep.
whatever value.
Yeah. So it'll be a function from that to that. So yeah.
Mm-hmm.
So what's the error?
Imagine
289. Is it?
actual, right?
Is that on? Can you show me again? If you put undefined in, just to double check, if you put undefined there, it all works fine. It all compiles fine, I should say.
I'm not tried.
Okay. No. Where are we? Line 287. Are we using the right source file? Or something?
What do you mean?
Well, it says that type error says line 287
Yeah.
is not, that's not the correct line. That's not the line that has a lookup call on it. So if you go back to the error message, have a look at the error message. Oh, sorry. No, it says something else now, right? So, oh, okay. Let's go back again. I believe you need to put an undefined. Let's put an undefined in the setter position. So just annihilate all of that. Does that compile? Right. So now let's do the get. So put that one back. Yeah. I believe that will compile. Yeah. The problem was the setter was wrong. So yeah.
That's kind of weird.
Yeah.
Okay. Well, I'll work on the setter then.
Okay. Yeah. Good luck.
Yeah. Thanks.
That's okay. But yeah, you're on the right track anyway. Oh yeah.
Lens is untitled.
Alright, eh?
Okay, so
Oh, right.
If modify, this is in get set, right?
yeah, I'm slow.
That's okay.
So my getter gives me a B. My function gives me an F of B. I don't see where to get an F.
That's right. So yeah, F is that. Okay, so
So this gives me a B. If I apply F to that, it gives me an F of B.
hang on, sorry, what is that? I can't see what. Oh, that's just G. Okay, right. So that's that. G on. Yeah. So now you've got you'll get a type error there, right? But you're on the right track. It's just returning you. What is that returning you?
G,
Just a B, right?
G, that gives me a B.
Yeah,
If
you've
I
got a
apply-
B.
If I go F of that, I get an F.
F of B. That's right. Yep. And then you need to F map through that.
Okay.
Right. So if you've got an F of B, then you F map through that with a function B to A, you'll get to F of A. Yeah.
Intuition for what choice is supposed to be.
Yeah. So the function choice, you mean? Just give me 1 sec, please. My work is annoying me. Okay. Yeah, so someone else asked a similar question earlier, and it's quite a difficult question to answer because I struggle to say anything more than what those types say, which is, to given a lens onto 2 target types to split out into choice on those 2 target types. So, yeah, I mean, that's what this type says, and I have a difficulty saying anything more than here's the use case. If we split between first and second, for example, where first goes on the left side and second goes on the right side, then when we do a get, we get that value there. And then clearly when we do a get there, we get that value there. So I guess I should do another. That's another. Oh no, that's okay. Yeah. So,
I might like to get a word implementation of those following types.
sorry.
If I just follow the types, type checkers in this one, will you get?
I mean, what I'm getting at is like when I'm telling you the intuition, I'm simply just saying what that type says. So I struggle to do anything more than that, other than provide you with examples and tell you what that type says. The only next best thing I could do is just say, let's start writing some real code, and let's see if you need that function, and I believe you probably will at some time.
Yeah, I guess that's what it is. when would I use this? Yeah.
Well, one day you're going to be writing some code in the near future, and you're going to have two lenses, and then you're going to go, I need to split them through either, and then I need choice, and that's going to happen. I just don't know what that code's going to look like until that day.
So, my understanding is nothing that you do on I did that originally. I did some sales professor.
Has anyone successfully done product on the optic lens?
I was buying.
Okay.
Well, not the way we need to say.
Okay. I'd be surprised because it's pretty mean. There's a bit of information missing.
I guess I just finished it, yeah.
Okay.
I have no idea if it works or not, though.
Okay. So you'll need these two data types. You'll need. Where am I? You'll need this data type here alongside right, and also this one here alongside left, and in particular you'll need their functor instance. Yep. So in order to complete the product function in the optic lens exercises, you'll need these two data types. Now, who is happy for me to solve, let's say, map L? Anyone still working on that?
Yeah, I'm working on it.
All right, I'll leave it then. Pardon?
I almost have it. Wait 5 minutes.
Yeah, okay, that's no worries. So I'll write product for the GetSetLens. Let's do the getter first. So the getter is going to be a function from pair AC to the pair BD. So I'm pretty sure that's get that one and get that one. This one's given the pair of A and C and the pair B and D. I need a new pair where this one is setted on the left side of the pair. So with that, set the target type to that value. S2 CD. Is that right? Oh, I imported Prelude. That's annoying. Oh yeah. What have I not done? Why did that crash? Line 331. Oh. GetSetLens. Ah. Did it again.